Example number 5. Comparing arrangements created with and without repetition. I love this question. It is so straightforward. It's very clear in seeing what is actually being asked of you in the question, and it is like based in real life. We actually do have sin numbers that consist of digits. The only tricky thing here is that there are certain restrictions in real actual sin numbers that we're not talking about in this question. If your card is issued in a specific province, it's attached to the first 3 numbers are your province number. But we're not going to worry about that for this specific question. What else it does is it shows you the difference between when repetition is allowed and when it is not, and how different the numbers or the number of ways actually are. When there are no restrictions, there are significantly more options available, whereas when repetition is not allowed, it restricts the number of possible codes significantly. So let's launch in here. A social insurance number, SIN, in Canada consists of a 9-digit number that uses digits 0 to 9. There are no restrictions on the digits selected for each position in the number. If there are no restrictions on the digits selected in each position of the number, how many SINs can be created if each digit can be repeated? How does this compare with the number of SINs that can be created if no repetition is allowed? So first, let's consider repetition. We would say that there are 9 digits. And so in repetition being allowed, there are 10 digits available for the first number, and the second number, and the third number, and the fourth number, and the fifth number, and the sixth number, and the seventh number, and the 8th number, and the 9th number. So when we multiply all these things together, it is 1 with 9 zeros after. That is 1 billion. Woo! So that means that 1 billion SIN numbers could be created. Let's think about it in the context of Canada. Do you think that's all right? What's the current population of Canada? Do you think that that would be enough for indefinitely? Do you think eventually we would need to change? What happens if repetition is allowed? Sorry, repetition is not allowed. Oh, before we go on to this one, actually, I want to make a significant note here. This cannot be expressed in NPR notation. NPR. Because the number of objects to choose from, it doesn't diminish. It doesn't go down. So since repetition is allowed, we can have 10 to choose from, then 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 10 to choose from. So essentially what we would be doing is we would say 10, pick 1, times 10, pick 1, times 10, pick 1, times 10, pick 1. However, when repetition is not allowed, we still have 9 slots. And due to the fundamental accounting theorem, we're multiplying all the time. We would start it with 10 digits, and then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2. Another way that we can express this is actually using that permutation notation. So we can say 10, and we pick 9 of them. Either way, we're going to get the answer of 3,628,800. So that is significantly less. 3 million versus 1 billion. The homework that I want you guys to work on tonight is from page 255, numbers 1 to 11, and then I also want you to do question 15. This is really important. There absolutely could be, oh no, that's not what I want. There absolutely could be questions on the test or on the final provincial exam that look a whole ton like, oh no. That actually look a whole ton like 15. So I want you to make sure that you know how to do that.